Beginner's Geo, Unit 1, and some good questions here. So it says ABC is an acute angle, and the measure of ABC is 4x minus 5. Find the restrictions on x. Well, being an acute angle means that it's less than 90. So 4x minus 10 has to be less than 90, but it also has to be greater than, or it's got to be greater than 0, because you wouldn't have an angle of 0. So it's got to be between 90 and 0. Okay, so those are the restrictions we're going to find out next. We're going to solve it. So we're going to solve this compound inequality, add 10 to all three sides. And now divide by 4. So 10 fourths and 25. So 10 fourths is 5 halves. X is between 5 halves and 25. Okay. And you can check it by plugging it in. Plug in 5 halves here, and what are you going to get? 5 halves. The 2 and the 4 would cancel. You get 2 times. That's 10. 10 minus 10 is 0. So it can't be that. It has to be bigger than that. If you plugged 5 halves in here, you'd get 0, and that wouldn't be an acute angle. So it can't be equal to that or less than that. It has to be greater than 5 halves. And if I plugged in 25 times 4 is 100. 100 minus 10 is 90. A 90-degree angle is not an acute angle. It's a right angle. So it has to be less than 25. Anything less than 25 would work, would give you an angle that was less than 90. Does that make sense?
Yep.
Given the diagram, solve for x and y. All right, so this is probably going to be a system of equations. So we know that these have to be equal to each other. So let's write that equation. 2x plus 7y has to be equal to 5x plus y. That's one thing we know. And then we know that these right here have to add up to 180. Or I could have said these have to add up to 180. Either one, doesn't matter. But I don't have to use both of them. So let's go 2x plus 7y plus 12x minus 5y equals 180. You understand why I said 180?
Yeah.
Okay, because those are a linear pair is what they're called. Okay, so now what I have is a system of equations. Now, do you remember this from Algebra 1? Solving a system of equations? Yep. You good with this?
Yeah.
So we're going to simplify both of these equations out, make them look a little bit cleaner. So let's put them in standard form, move everything over to the left. So subtract a y, subtract 5x, you get negative 3x. Subtract y, you get positive 6y equals 0. For this other one, you're going to get, you're going to have, and correct me if I'm wrong on any of these things, because sometimes I make mistakes when I'm going fast. Does it look like I did that right?
Yeah, that looks right.
Okay, so what should I eliminate in order to solve this system?
Probably the y's.
Perfect. And how would I eliminate the y?
Multiplying the bottom, the red one, with by -3.
Perfect. Or you could totally do that, but wouldn't it also work if I divided by -3, the blue one?
Yeah.
And the reason I say that is because it'll just simplify your problem a little bit.
Okay.
Because then this would just be x minus 2y equals 0. I mean, it wasn't hard to divide by 0, right? And see how now that's just going to be an easier thing to do. So I would say that with the way you said it would have worked as well, but I'll give you that suggestion to make it easier. So what does x equal?
Hold on. X is, sorry. X is 12.
Good. So if x is 12, what is y? And also the reason why you did that is because see how much easier it is to plug it into this one.
Yeah.
X is 12, Y has to be 6, right?
Yeah.
You can kind of do that in your head, can't you?
Mm-hmm.
So 12 and 6, and let's just make sure that works. Go up here to plug in 12 and plug in 6. You get 56. That's 66. Plug in 12, that's 24, plus plug in 6, that's
42, I think.
42, and that's 66. Yeah, so that checks out. Plug in 12, that's 144 minus 30, that's 114, and that checks out as well.
Okay.
Got it?
Mm-hmm.
Oh, the hands on a clock. So the reason that this is tricky, it's because it's not really as simple as you think. But you kids these days don't really know how clocks work, the old-fashioned clocks. And the way they work is this doesn't line up exactly. This 2 hand, if it's 2 o'clock, I'm sorry, if it's 2:50, this would not be here.
Mm-hmm.
See, there we go. This would not be sitting at the 2. This would be sitting closer to the 3.
Yeah.
You know that?
Yeah. I messed that one up. Yeah.
Yeah, well that's the tricky part to this. So I'm going to erase that hand. Okay. So that's gone. So now we can, if you think about how many, there's 180 degrees, right, in a circle. Oh, that's not true. What am I saying? There's 360 degrees in a circle, right?
Mm-hmm.
And I'm dividing that up by how many settings am I equally dividing that by? Or how many numbers are on a clock?
12.
There's 12. So what's 360 divided by 12? It's 30, right? So 30 degrees. This is 30 degrees. This is 30 degrees. This is 30 degrees. And this is 30 degrees. But then I'm going a little bit more, and that's the big question. What's the little amount more that I'm going here? So we're going to have to come up with kind of a formula for that. So I know that those blue ones are each 30 degrees, right?
Mm-hmm.
So 30 plus 30 plus 30 plus 30. So that's 120. But then what's that little yellow piece? Well, let's think about it. That yellow piece is the same fraction of the whole that 10 is to 12. So what I'm going to do is I'm going to take 30 degrees and I'm going to take 10/12 of that. I'm taking 10/12 or 5/6, right?
Mm-hmm.
I'm taking 5/6 of 30. So do you know how to simplify fractions easily? I'm guessing you don't, just because of COVID. So here's how you do it. 30 is really 5 times 6, right? So think of it like that and cancel the 6's out. And then multiply the 5's together. So it's just 25. So this little yellow piece right here is 25 degrees.
Okay.
So 140 was the blue, right? And then plus 25. I'm sorry, 120, my bad. 120 degrees plus 25. And that's how you get your answer, which should be 145 degrees.
Okay.
Make sense?
Yep.
So do you understand that formula, how I came up with that?
Yeah.
All right, sounds good. And I did not mean to demoralize you and say that you didn't know how to do that trick, but it's not really a trick. I just know how difficult it has been the last couple of years. So I won't assume anything. I'll just teach you all the cool the cool tricks that I like to teach people.
Yeah. Okay.
Sound good? If two
Mhm.
sides of A, B, and C are 5 and 8, what are the restrictions on the third? Well, you know that the triangle inequality theorem, I think it's called, is the one side of a triangle is always has to be smaller than the sum of the other two sides. You can't have a triangle. Think of it like this. If I had a triangle that was 5 and 8. So here's 5. Let's draw the 8 here. There's 8, and here's 5 is over here. I'm going to try to draw it as wide as I possibly can. 5 is right there. This third side right here has to be, it cannot be 5 plus 8 is 13, right? This cannot be greater than 13. That cannot be equal to 13.
Okay.
Because this right here had to have some sort of an angle here, right? And so if I were to put that flat here, 5 and 8 would have equaled 13, right? But it's not flat. There has to be an angle there. And so that's why this cannot be 13. It has to be less than 13. So that's one way you can think of it. It can't be bigger than 13. But then the other thing you can think is, well, let's assume that this is the smallest side, that the unknown side is the smallest side. So it's got to be less. 13 is the max, so it has to be less than 13. And if the missing side was on the smaller side, then that would mean 8 would have been the bigger side. So we'll call this x. X plus 5 has to be greater than 8. Do you get what I'm saying?
Yeah.
So solve that inequality and you get x is greater than 3. So
Okay.
on the lower side, it has to be greater than 3. And on the bigger side, it has to be less than 13. So I kind of taught you that, but here's the little shortcut. So the shortcut is you just add the two numbers together, and that's the max part. And then you subtract the two numbers, and that's the min part.
Okay.
So it's actually an easy thing to do, but I figured it would be good for you to understand. Questions about that? Are you good?
Nope, I'm good.
All right. Given the diagram and ABC is a right angle, is this ABC over here? Yeah.
Yes.
Okay. So if that's a right angle, I'm just going to go ahead and write this. 3x plus 2x equals 90. So 5x equals 90. So x equals, what's 90 divided by 18?
Yeah.
Okay. So it's as is D, B, C, F. I don't get what the question is.
Hold on. I can fix it. Just give me a second.
Oh, got it. Okay. By the way, are you using a textbook? Or is
These
it
are just these are problems that I just found.
Oh, okay. What a lot of times kids will do is they just take a screenshot of picture of problems straight from their Chromebook.
Okay.
I mean, I don't mind that you're doing it like this, but take a screenshot of questions as you're going throughout the week and just kind of create a Jamboard. And then as you're going, if there's things that you don't get from your homework, throw them on the Jamboard. Makes sense?
Mhm.
ABC. So F is DBC. I still don't get what the question is. Is DBC? Where's D at? It says, is
I have,
DBC
I
something
have,
about,
oh, wait, sorry, this is my fault.
oh, is it equal to F? I got it. So is this equal to F?
Yeah,
Okay, so 2 times 18 is 36, and 18 plus 18 is 36. So yes, the answer is yes, because you solve for X.
okay.
Good. All right, indicate whether each statement is always, sometimes, or never a segment has a midpoint. Well, let's think of what a segment is. A segment is just it's a line segment. So it's part of a line that ends at both sides. So does every segment that you can draw have a midpoint?
No.
Can you think of an example of one that doesn't? Does this red one that I just drew have a midpoint?
No.
You sure? I mean, I didn't draw it, but does it have a midpoint?
Yeah.
Yeah, it has a midpoint. It's whatever the point is in the middle. You don't have to put the dot there. It still has it.
Okay.
You get what I'm saying?
Yeah, so it always has a midpoint.
So this
Okay.
would be always.
Right.
Okay. If
Mhm.
if you can think of an example of something that doesn't, then that would be never, or it could be sometimes, because if you can think of if you can find where it can happen, but it doesn't necessarily have to happen, then it would be sometimes. But in this instance, it's always.
Okay.
These are logical. These are logic statements, so they're kind of tricky. It's kind of
Mhm.
hard for you to know sometimes, but yeah, that practicing is how you get better at it. The next one says the sum of two obtuse angles is obtuse. So think of an example. What is an obtuse angle?
Angle over 90 degrees.
Good. So let's take the two smallest ones we can find. How about 90.1? Is that obtuse?
Yeah.
Yeah. Plus 90.1. Is that obtuse?
Mhm.
Yeah. And what is that going to add up to?
180.2.
Yeah. And is that obtuse?
Yeah.
Yeah. So what is
So,
the answer to this?
so it's always?
Always.
Okay.
Well, hold on a second. All right, well, hold on. Now this makes me think a little bit different about how are they talking about? Well, now let's think of some bigger ones. What's the biggest angle you can think of?
The biggest angle, 359.
Okay, so let's just go 350 plus 350. That's going to be 700. Do you know what a 700-degree angle looks like?
It's like basically a circle going around pretty much twice.
Yeah, it keeps going around in a circle, but I still think that that's an obtuse angle.
Okay.
Because they're not talking about the reference angle. Have you learned about reference angles yet? I don't even know if you have.
No.
So you start here on the initial side. This is called the initial side, and you go like this. So there's 350. And then if I go another 350 around from here, there's another 350, and I'm at 700, which is like here. Right? But
Yeah.
the reference angle would be this angle right here.
Okay.
But that's not what they're talking about. They're still talking about that angle, which is still obtuse. So yes, I would say always.
Okay, but my teacher, that was one of the questions that I had on an assignment, and my teacher said that one was when I put always, she said that it was wrong.
Really?
Yeah.
Did she give an example of one that was not?
No. No, she just marked it wrong.
I wonder if she's thinking of, who's your teacher?
Miss Myrick, she teaches at Mattia.
Okay. Sum of two obtuse angles is obtuse. I mean, I can't imagine what she's thinking of unless she's calling a negative angle obtuse.
Maybe, I don't know though. Because you can't have a negative angle.
Well, right. No, well, you can. You can have one, but that's what I'm saying. What kind of angles are we referring to here? I would need to see your definition of an obtuse angle. So let me do a little quick search here.
Okay.
Okay, let's just do definition of obtuse. See, it kind of depends if you're talking about geometry or trigonometry.
Yeah.
Oh, that's why. Because they're telling you that it has to be less than 180.
Oh.
So they're not calling that 700-degree angle obtuse. They're only calling angle. That's why. So in your definition, in the geometry definition, actually, so it should be never then. The answer should be never.
Okay.
Because if you have an obtuse angle, it has to be greater than 90. And when you add another obtuse angle, now that has to be greater than, that's going to be greater than 180. And that is not an obtuse angle according to your definition.
Okay. Okay,
Yeah.
that makes sense.
Yeah,
Yeah.
my fault. You know what? I was not thinking of geometry. Right. I was thinking of trig. I was thinking of this, and yeah, that's not. Yeah, my fault.
It's okay.
Definitely. It should be never, not sometimes. It's never.
Okay.
And how about this one? Did you have that one too?
The segment is midpoint. Yeah.
And what was the answer?
I put sometimes.
Yeah,
but I don't know.
Yeah, it should be always.
Okay.
Because, and again, it's kind of hard because you have to know the definition. So these logic statements, you kind of have to, you really have to be keen on the definitions of what we're dealing with in order to answer them. So the definition of a segment is a line that ends at both ends. You know, it's not a line because a line doesn't end. It's a finite, basically it's a finite line on both ends. And since it's finite, there is a midpoint.
Okay.
Because it's not, there's no tricks to it. It's not like it can't have a break in it. It wouldn't be a segment. If it allowed you to have a break in it, then you could say, oh no, there's no midpoint here because see, look, there's a break in that line. Well, that wouldn't be a line segment. A line segment is defined. Again, you have to understand that you have to know the definition of it, but the definition is that it is a continuous collection of points, collinear points between two endpoints or something like that. You know what I mean?
Yeah, that makes sense.
So the definitions are important for those things.
Okay.
All right. Was that it? Or do you have another question?
That's it, I think.
All right. Well, hey, it was good to meet you, Elliot.
You too. Thank you.
That helps. Sorry, I'm not feeling well today. I've been out sick today. I got COVID, so but I'm feeling good. So